right, in this lesson, we're going to start with the basics of med calculations and give you a good foundation moving forward. Now, guys, first and foremost, we want to tell you that med math does not have to be your arch nemesis. I know that it's something a lot of people struggle with. We promise we're here to help. I'm not going to lie. I'm kind of a big nerd, and I actually love this stuff. So what I'm going to do for you is show you the 3 main formulas you need to know. That's right, only 3. And then I'm going to give you a simple 4-step process for all of your calculations. The purpose of this lesson is to establish a foundation and the process. We also have a whole lesson on dimensional analysis, if that's a method you prefer or that your program uses. And then we have individual lessons for different types of calculations with lots of examples. So make sure that you check those out. Okay, let's get started. There's only 3 main formulas that you need to know. There are some rare times that you may need something different, but for 95% of what you're going to need, these 3 will cover it. Now, the big thing to know here, though, is this is all just basic algebra. I know sometimes we see the word problems, we get intimidated by the medication math aspect of it, but it's not complex calculus. We're just solving for X. It's basic algebra. Okay, the 3 main formulas that you need to know are for dosages, so like how many tabs to give, how many milligrams or milliliters, etc. Infusions, so rates, volumes, and times. And then drip rates, which is typically in drops per minute. GTT, remember, is the abbreviation for drop. So let's look at each one of these. Your first formula for dosages is this. The dose equals what you want, so that would be what's ordered, or the desired amount, over what you have, so that would be what's available, and then times what it's in. So what form dose does this drug come in? So here's an example. The provider order is 650 milligrams of acetaminophen, and you have available 325 milligram tabs. So how many tabs will we give? So the dose equals what we want, which is what's ordered, so 650, over what we have, which is 325, times what it's in. Well, what is that 325 milligrams in? 1 tab. Okay? So 650 milligrams over 325 milligrams times 1 tab. Now, the best part about these formulas is that you can actually solve for any part of this formula, just like basic algebra. So let's say a patient reports taking 2 tabs, and those tabs are 325 milligrams in 1 tab. And the question is, what's the total dose that we took? Okay, so again, it's basic algebra. We just move the variables around to solve for, in this case, X, which ends up being the 650 milligrams. So again, basic algebra. Dosage, what you want over what you have, times what it's in. Now, the next one, infusions. Now, this is a great formula because you can solve for rate, volume, or time with this one formula. Again, it's just algebra. So remember this, rate equals volume over time. Rate equals volume over time. Now, usually if we're talking about, IV pump infusions, we're going to talk about milliliters per hour, volume over time. But you could also see milliliters per minute, liters per hour, any volume per any unit of time. Just make sure that whatever you're doing, all of your units match up. So units equal units. So if I say we're giving 1,000 milliliters over 8 hours, what's the rate to set on the pump? Well, anytime you see set on the IV pump, we're talking milliliters per hour. So 1,000 milliliters over 8 hours is 125 milliliters per hour. We could also rearrange this formula to solve for anything. So it's basic algebra. If we multiply by time on both sides, what we see is that rate times time equals volume. Then if we wanted to solve for time, we could just divide by rate, and we would have time equals volume over rate. So you can see here that you can solve for rate, you can solve for volume, and you can solve for time all in one formula. So remember the magic formula, rate equals volume over time. The next formula is actually kind of a specialty version of the last one. Instead of just looking at general infusion rates, we're looking at drip rates specifically. Now, this is the number of drops or GTTs per minute. We actually use this when we're hanging infusions over gravity instead of with a pump. It doesn't happen very often, but it can be really helpful if for some reason that you don't have a pump available. So what you're going to notice here is that our rate equals volume over time formula that we just looked at is still here. The difference is that we have added the drip part. So instead, it's drip rate equals volume over time times the drip factor. Now, what is the drip factor? Every set of tubing that we use has a drip factor that tells us how many drips there are in 1 milliliter. So this is the drip factor part. A lot of times, standard IV sets are 10 drops per mil. And then something called a micro set is 60 drops per mil. There could also be 15 or 20, etc. So let's just do a really quick example. You are administering 120 mils over 30 minutes with a drip set that has a drip factor of 15 drops per mil. Okay, so let's set this up. Volume 120 over time 30 minutes times our drip factor 15. Okay, now this is 15 drops per mil. So you can see if we cancel out our milliliters, we have drops per minute. Okay, when you multiply this out, you end up with 60 drops per minute. One thing to know with drops is always round to the nearest whole drop because you can't do a quarter of a drop. Okay, so those are the basic formulas. Now I just want to run through this 4-step process. We really think this is going to help you with your med math. So I'm going to use one example through all 4 of these steps so you can see what it looks like. The 4 steps are identify, convert, solve, and verify. I remember I can secure victory with MedMath. Okay, so step 1 is identify. This is all about identifying your variables. What are you working with? What are you looking for? What's the order? What do you have available? And based on all of that, you can decide what formula to use. So here's our example. The provider has ordered for you to administer 60 milliequivalents of potassium chloride IV over 4 hours. The bags from the pharmacy contain 100 milliequivalents in 1 liter. What rate should you set the IV pump at? Okay. So what's ordered? Well, 60 milliequivalents of potassium over 4 hours. So I've got a dose and I've got a time. What do I have available? 100 milliequivalents in 1 liter. That is our volume. So now I have a volume and a time. Well, what am I looking for? Well, the question was what rate to set the pump at, which is always in milliliters per hour. So now I know I have a volume, I have a time, and I'm looking for a rate. So I'm using the infusion formula. But I also need to determine how much of that bag I'm giving. So I'm going to use the dosage formula as well. So we're going to start with dosage, and then we're going to use the infusions. It's okay to use more than one formula. The second step is to convert. The goal here is to get all of our units to match. If I'm looking for milliliters per hour, I need everything in those units. So my available amount was 100 milliequivalents in 1 liter. So I need to convert these liters to milliliters. So instead, now I know it's 100 milliequivalents in 1,000 milliliters. Again, we're just doing that conversion. This is also where you can do a weight-based conversion if you have it. You just have to know your conversion factors. We do have a whole cheat sheet on it attached to this lesson. You just have to know them, okay? Now, one big note here is about rounding. Here at NRS&G, our official stance is that you should never round anything until the very end. That ensures the most accuracy, and it's especially important in pediatric dosing. However, we do know that some schools request that you convert and round along the way, so just make sure that you know what your school requires when it comes to your school exams, okay? So now we've identified all of our variables, what formulas to use, and we've done our conversion to get everything into the units we're looking for. So once you have that information, we need to solve. So we're going to use our formula. So for this example, we need to first determine how many milliliters we're going to give and then what rate it's going to be at. So our dosage formula, dose equals what we want, 60 milliequivalents of potassium chloride, over what we have, which is 100 milliequivalents of potassium chloride, times what it's in, which we converted and determined was 1,000 milliliters. So once we do this math, what we determine is the total dose we need to give in milliliters is 600 milliliters. Now we can transition to the infusion formula to find our rate. Okay, so rate equals our volume, 600 milliliters, over our time, 4 hours. 600 divided by 4 is 150 milliliters per hour. So we used the dosage formula and the rate or the infusion formula. It's just basic algebra. Now, the very last step is always verify. This is the point at which, in our opinion, you'll do any rounding that you need to do. You'll triple check that you have the appropriate units in your answer. In this case, the appropriate units are milliliters per hour. And then you're going to ask yourself if it made sense. We had 100 milliequivalents in a liter. We're giving 60. Let's say 600 milliliters makes sense because dividing that over 4 hours is 150. It makes sense. If you had, let's say, if you'd missed a conversion and you had used the 1 liter instead of the 1,000 milliliters, what you would have come up with is 0.15 milliliters per hour. At that point, that doesn't really make sense to do that for 4 hours. And so if you get a result like this that doesn't make sense, go back to the beginning and check all of your math. So remember these 3 main formulas, the dosage formula, the infusion formula, and the drip rates. Remember the 4-step process. Identify what you have, what you need, convert to the matching units, solve using the appropriate formula, and then verify that you have rounded, use the right units, and that everything makes sense. Make sure that you know your conversions, and then make sure that you know your rounding rules. Again, your school might be different, but in our opinion, it's safest to round at the very, very end. Then more than anything, just remember that we believe in you. You've got this. You can do this. Practice, practice, practice. The more that you do these med math calculations, the better that you'll get at them and the more confident you'll be. All right, guys, make sure you check out all of the resources attached to this lesson and keep practicing.